Now that we have our spontaneous reaction, we want to be able to sketch out the battery and label all the components in a battery. So all of the chemicals that are part of this overall reaction are going to be needed to make a battery. And what I have here is the two components. So you have a beaker on the left and a beaker on the right. One side has the copper component, so I have copper and I have copper 2 plus because those are the two chemicals in the overall reaction. Copper is a solid. Copper 2 plus is aqueous, and you can't have a solution with just cations, so I put in 2 nitrates to neutralize the positive 2 charge on the copper. The other side of the container, I have a solid piece of zinc. I have zinc 2 plus, because again, those were the two chemicals in the overall reaction. I can't have just positive cations in solution, so I put in 2 nitrates. The copper and the zinc, these are the terminals or the electrodes on the battery. And the electrodes are connected together. We have a conducting wire, and I'm powering a television in this case, and the television is connected to both terminals or both electrodes. In between, we also have a salt bridge that contains the salt potassium nitrate, and we need that to make sure that the charge in both beakers stays neutral. We have to keep the two components separated from each other, otherwise the spontaneous reaction would take place and we wouldn't have a way to tap into that direct current, which is caused by the electrons that are being transferred from one side to the other. So on the zinc side, the zinc is being oxidized. Zinc is losing electrons. It's going from a neutral zinc into a positive 2 plus. So you can imagine one atom of zinc leaving the solid and dissolving and forming zinc 2 plus. At the same time, the other product that's made is 2 electrons. So the 2 electrons will travel on the conducting wire through the television and to the other electrode. The electrons then travel through the copper, and the 2 electrons connect with the copper 2 plus in solution, and they're going to form an atom of solid copper. So one electrode is increasing in mass. The copper electrode is getting a little bit heavier as the battery operates, and the zinc electrode is dissolving, so it's becoming a little bit lighter in mass as the battery operates. At the same time, notice what happened. The beaker on the right started out electrically neutral, but now we put in 2 more positive charges. The beaker on the left started electrically neutral, but it lost 2 positive charges. This is why we need the salt bridge to keep everything neutral. When the beaker on the right has an excess positive charge, the anions in the salt bridge, in this case nitrate, are attracted to that positive charge, and so 2 nitrates will leave the salt bridge and go into the beaker on the right. At the same time, the potassium cation is attracted to the net negative charge in the beaker on the left, and 2 potassiums will leave the salt bridge and make the beaker on the left stay neutral. As long as the 2 beakers are neutral, this process can repeat itself and we get a constant flow of electrons from one terminal to the other terminal.